So let's dive into how to prepare your prop for baking. I've wanted to make this video for a while now because I've noticed a pattern of questions whenever I share my process on X. It's clear that some universities are still teaching outdated or incomplete or even just wrong methods for creating game-ready artwork, leading to misconceptions like triangles are bad or that models must be one single continuous mesh. And when it comes to preparing your model for baking, you need to get a couple of things right for the best results. And in this way, I think universities need to do a better job with teaching these processes and concepts. So I'll be showing you my approach to preparing game-ready assets using this car radio I made for Rust as an example. My goal here is to help you create great art while minimizing the headaches that often come with this process. And along the way, hopefully dispel some silly myths. So with that, I've split this up into chapters, so if you want to skip ahead, make sure to check out the chapters in the video. So we're going to start with finalizing the UV unwrap. So I'm going to jump into Blender, and even though I'm using Blender, a lot of these concepts, if not all of them, will be software agnostic. So if you're using Blender, 3ds Max or Maya, then it's all good. The theory and practice still applies. Here I have my car radio model. The mesh is complete and so are the UVs. I'm going to assume that you have your own game ready mesh and UVs complete too, but we just need to run through some checks before sending this to either Marmoset Toolbag or Substance Painter. I personally use Marmoset Toolbag because I think it's superior. There's just way too many features that make it a pleasure to work with. But in any case, let's open up the UV editor to do a couple of checks. The first thing I want to check is that I've actually unwrapped everything. There's been too many times in the past where I've thought I've unwrapped everything, and I've gone through the baking stage and even into the texturing to finally and fatally realize that I hadn't unwrapped a bolt or some hidden section of an asset. It sucks. So one thing I do now is to first, before I even start UVing, is to create two temporary materials. A red material to display what hasn't been UV'd, and a green material to apply to parts after I've unwrapped them. This just helps me keep a log of what I've done, well, a visual log, and helps me to spot any parts that need unwrapping before baking. It's a huge time saver, honestly. The alternative is to simply apply a checker map texture to the whole object and see if there's any crazy UVs on any parts. The next thing I want to check is entirely dependent on the object and whether it contains any duplicated or mirrored geometry. Now this is especially important for mirrored geometry because you'll need to mirror it before baking to get the cleanest results. In this example for the car radio, I have a couple of pieces that are duplicated and mirrored, and this is really just to save UV space and to increase the resolution I can work with. So for example, this top section of the radio, the black leather, this will be duplicated by using the mirror modifier, so I can have a bottom to the radio, just like in the reference. I don't need it to have unique UVs because most of it will be hidden and you'll never see it from that angle, so duplication is a great, efficient way to save UV space. I've just applied the mirror modifier, and what this does is not only mirror and duplicate the geometry, it also does the same for the UVs, except it just overlaps the duplicated UVs to the original. And this is an issue for when we bake and texture our asset. Generally speaking, we want to avoid baking our asset with overlapping UVs. This will increase the chances of causing a bunch of bake errors, especially in Substance Painter. And it could produce some really odd shading, especially in the 2D view. And so if you're finding that, this is most likely the cause. So we want to make sure we fix this before it becomes an issue. To resolve this, all we have to do is to go into our mirror modifier and into the data subpanel. And here we see a bunch of data values for the UV, and we have the option to mirror our UV or to offset it. And we want to offset it by a factor of 1. Now you won't really see anything until you apply the modifier, so let's just do that. And even though the UVs are no longer in the 0 to 1 UV space, because the UV's tile is technically still showing the same space, but it's just offset and no longer overlapping, helping us to avoid any nasty bake errors. Now, if you've already applied the mirror modifier, that's okay. What you need to do is to select the geometry that has been duplicated or mirrored and offset that. I would advocate to use a free extension called UV Toolkit, which can be found in the extensions panel of your preferences. And within UV Toolkit, we have a handy little transform function. We can offset the selected UVs by a factor of 1. One other reason why we do this outside of avoiding baking errors is because when we are working with duplicate or mirror geometry and UVs that are offset outside the 0 to 1 UV space, we can't actually directly paint on that mesh in Substance Painter. We can only paint directly on any geometry that has its UVs mapped to the 0 to 1 UV space. So we want to offset the correct parts so we avoid any texturing issues that may cause confusion down the line and avoid any re-exporting and rework. So if you're working with duplicate or mirror geometry and you're wondering why you can't directly paint on parts, then this is most likely why. So make sure you've correctly offset any duplicate or mirror geometry. The last thing I check when it comes to finalizing the UVs is just making sure that I've set all my hard edges. Now this is typical for hard surface assets more than organic assets, but generally whenever we have a UV seam, we will want to have a hard edge, and this is to help the normal map deal with more severe changes in surface direction. Now this isn't always the case. UV seams don't always require a hard edge if the change in surface direction isn't too severe, like 90 degrees, but you will need a UV seam wherever a hard edge exists to avoid any baking issues because the mesh smoothing has changed. Now, to quickly do this, I typically use UV Toolkit, which once again has a nice little feature where we can automate this process. After selecting all of my UVs, I run the Sharp Edges from UV Islands tool, which just sets all the UV border edges to hard, or in this case, sharp. Then I'll make sure to check over the mesh to see if there's any edges that might not necessarily need hardening. If the change in surface direction isn't severe enough, like this cable at the back here, we can just select that edge loop and disable the sharp or hardness of it. So as you're finalizing your UVs for baking, make sure you've properly set your hard edges. Remember, not every seam needs a hard edge, but if you do have a hard edge, you will need a UV split there. The next chapter is on mesh integrity, whereby we're going to make some checks around the mesh to make sure that there aren't any glaring issues with the mesh itself, so we don't have to do any extra work down the line. So the first thing I do is to make sure there's no flipped faces. When working with duplicated geometry, especially duplicated geometry that we mirror, we can at times find that the faces get flipped, and it's not actually all that obvious to begin with. Now, I'm not talking about using the mirror modifier like we did with the black leather here on this section, but rather the built-in mirror function. Let me show you to explain. So we have the base of this dial here. We want to mirror across here. So sometimes I will just duplicate it across and like that. And if I want to, I don't know, change things up, I will right click mirror and then either mirror X or global. Now, if we go to face orientation, we can see where the flip faces are, the interior faces versus the outside faces. The outside faces are blue, the interior faces are red. And it doesn't look like it's inverted at all until we reset all the transforms. And we actually have to do this later on, which I'll explain in more detail. But when the transforms are applied and all the values are zeroed, the normals of the mirrored object are flipped. But it may actually not be all that obvious when you come out of face orientation mode or if you didn't use it to begin with. So when you do mirror any geometry and you apply the transforms of your object, do make sure to check for any flip faces by using the face orientation mode. If you do find any face normals that are flipped, there are a couple of ways of doing it. The first way is to select all the faces and to search for recalculate outside. Or alternatively, if we have the faces selected again, search for the flip operation. And that's it, resolved. So just go around the mesh using the face orientation mode in the viewport settings, which you can find the geometry tab of the viewport overlays by default, or if you have hard ops installed, you can find it in the viewport tab. The next thing I want to do is to make sure that we've zeroed all our transforms. Now, this is a bit of a strange one because it doesn't, well, it might not directly affect your bake, but it's really good practice to get this nailed down even before the baking stage. So I always make it part of my pipeline to make sure that all location, rotation, and scale are all zeroed. Now this might look different for those different sections. So scale, you want to have the X and Y and Z all at 1, so it's all 1 to 1, and the rotation and location data all set at 0. And you can't just set them to 0 because then you'll find that parts shift around. So the solution to this is something that you saw me do with correcting the normals of mirrored objects, and that is to, and I've got this hotkey or to set to my quick favorites, is all transforms, and that is simply to apply the object's transformation to its data. So you're applying all of this data that you see here and basically setting it as its default values. So you can find this just object apply all transforms. So now we see in the location data, the rotation data and the scale data has all been defaulted back to its original scale by applying those values as the default. Again, this might not, you might not see any effects in the bake, but down the line when you are implementing the asset in Engine and you're trying to place it around, or a programmer is trying to implement the object, or even for animation's sake, in fact, if there's any animation involved, there's going to be issues with implementing this asset if it hasn't got its rotation, location and scale all zeroed out. So make sure we do this even before the baking begins, so everything is unified, everything is just simplified from the get-go, and you don't have to do anything after baking or even after texturing, because that's just the worst case scenario. Let's get these things sorted here and now at the baking stage, even before the baking stage. The next round of checks we do is concerned with the names of our objects. But first and foremost, you may have noticed that there are a lot of parts to this object, and you may have been told by a certain university professor that that's a big no-no. Well, you can tell them that that idea is a big no-no because it really doesn't matter, especially when it comes to baking. And in fact, it's more desirable to have them broken up like this so you can adjust the bake settings for each part far more easily and thus have more control. Here you can see in Marmoset Toolbag that I have quite a few bake groups, and these are all the different parts that you saw then in my outliner in Blender, all separated, and thus I have access to the cage of each segment and I can make individual adjustments to the bake itself, and that is a good bake. So on to the names. It's important that we get the names right here, and it's more for organization than anything else, especially if you're using something like Marmoset Toolbag that has a quick load feature that relies on proper naming conventions. I have found, and it may have changed by now of this video releasing, that if I don't have proper matching names of the object and the data of that object as the same, then I get import issues with the quick loader. Again, this may have changed now, but I always make an effort to make sure that they match one another. So just go through your parts and just make sure that each of the names are matching it. And if they're not, then let's change them. Let's call that down knobs 2, for example, and let's copy that and change that over. Let's call that down knobs 1. There we go. That's more like it. But again, just go through each one of them and just make sure that the names are matching. It's also, it may also be a little bit of OCD that I have there with this, because it just drives me up the wall if they're not the same. And it also helps to identify each part more easily. The second part to this naming thing is making sure that you have consistent naming conventions for the suffix. Here I typically use either underscore all capitals low or LP. More traditionally I use LP for low poly. And for the high poly, as you can see in Marmoset Toolbag, if you can squint enough, for the high poly I just have underscore HP. And that seems to work quite nicely for me. So just go through and make sure you have proper naming conventions and proper suffixes, just so you can tell each part and where they belong in each bait group. The very last thing I check is also the thing that I get asked about the most: triangulation. Let me be clear, if any tutor or mentor or university professor tells you that triangles are bad, then I can absolutely guarantee you that they have no clue what they are talking about. Now, some triangles are bad, but mostly, generically speaking, they're not. So either they're just ignorant, or they haven't spent any meaningful time in the industry doing this, or they themselves have somehow been taught the wrong thing and are passing it on like a generational curse that needs breaking. Either way, they are woefully wrong, because as soon as you bring this into baking software like Marmoset Toolbag or Substance, or more importantly into an engine, the engine is going to, behind the scenes, triangulate your mesh for you. And it might do it in a way that isn't so great, causing shading errors because there is a tangent mismatch because you haven't triangulated your mesh before baking. So how do we prevent shading errors and tangent mismatching? We triangulate before baking. So from baking to engine, everything is the same. You have complete control over it. And in Blender, we do this in a way that's really, really simple. One way we do it is on export. Let's say we were using OBJ, and let's find a random place for this. And in the settings, we tick triangulated mesh. The problem with this, even though it does triangulate it, we still don't have the kind of control that we want. And so to get the ultimate control over this, we simply just add a triangulate modifier to everything. And the quickest way to do this is through hard ops and to add a triangulate, which does it to everything. And holding Alt down whilst changing the value here, we can change the value from 5 to 4. Triangulating the entire mesh, and we can go and have a look to see if it's triangulated in a way that we like, or if we don't like, and we can change it there. So for example, if I wanted to triangulate like this, we can just connect those verts and then we have control over it that way. Otherwise it will look like this, which is again fine. And then we can export. And this is how we avoid those horrible baking issues and tangent mismatches, is to triangulate beforehand. Yes, triangulation is completely fine, and it's what we must do to ensure the best results for baking. Now this wasn't an in-depth look at the technical reasons why we do the things we do to prepare a mesh for baking. Even though we did talk about it in some depth, I didn't want it to overwhelm you with the nitty-gritty, but I would wholeheartedly admonish you to read up on the different aspects here that we've spoken about, so you have a greater understanding on the topics for yourself, and you can inform those pesky university lecturers. Marmoset has a great resource and documentation on some of these issues on their website, so please do read up. I'll leave the link in the description below. But I hope this has been helpful, and if it has, please do tell me in the comments below. Peace!